possible, taking into consideration your budget. So we're going to extend that a little bit more today. I think I want to look at what happened there at the optimal condition. So let me just kind of rehash here. Consumer problem. Choose QB and QP, the quantity of beer and pizza. So these are what we call our choice variables. These are the things we're choosing. Choose beer and pizza to maximize total utility subject to a budget constraint. Now, the last thing I left you with was in terms of a technique of how to find that optimal amount was looking at the bang for your buck. What were those two columns that we created, those last two columns we added at the end? Marginal utility, and there was a relationship. The last column was, what did we do? We created kind of a new statistic, if you will, our new variable. Per dollar, yeah. So how did we get it exactly? We took marginal utility and did what to it? Divided it by the price of the good. And this kind of leveled the playing field for us. So if we had the marginal utility of beer divided by the price of beer, gave us the bang for our buck, right? So it's per dollar, how much satisfaction per dollar we were getting. And then in equilibrium, when we also, first of all, we did the same thing for pizza. And what did we find in our solution to the problem where the optimal amount of beer and pizza was? What was true about these two statistics? Look at your table of numbers. I won't recreate it today.
Are you looking for the total number?
Yeah.
It was 4 beers and 3 pizza.
It was 4 beers and 3 pizza. And what was the marginal utility per dollar for pizza at that level, at the optimal level of 3? 5. What was the optimal per dollar, satisfaction per dollar for the 4 beers? 5. So that ends up being kind of a clue to how we maximize utility. These two things need to be equal, and we kind of played that game as we went through and spent our money. The way Jacob brought it up was, where should I spend my next buck? Should I buy a beer or should I buy a pizza? Well, it depends. What's my bang for my buck? So in the equilibrium, at the optimal quantities of beer and pizza, we find that that has to be true. So this is what we call the utility maximizing condition. This condition must hold in equilibrium. This is the utility maximizing condition. What does it mean to be a condition? Well, it just means that this must hold in equilibrium. So this might be better off as a question to kind of reflect on it. What if it didn't hold? What if the marginal utility from beer divided by the price of beer was greater than the marginal utility from pizza divided by the price of pizza? In other words, what if they weren't equal? What would that tell you that you should do? Yeah, you should do some adding and subtracting. What do you need more of? Beer and less pizza. Now, if you only have $10 or $100, if you have some amount of income, what does that mean you should do with your budget? Adjust it. Adjust your spending, right? You've got a fixed amount of budget. You'll be happier if you take some of those fixed dollars, if you have a $100 budget, and shift more of that over to here. That'll make you happier, is what this condition says. So this will hold when you have got the absolute optimal. If you don't have the optimal, then you need to reallocate your budget. So this question, what if this is true? The answer to that is then you can be happier by reallocating your budget and increase your quantity of beer and decrease the quantity of pizza. Take that fixed amount of money in your budget and reallocate. Okay, questions there? Here's another little nifty thing we can do with the condition that gives us some additional insight. Let's call this equation, I guess I kind of got a star over here, so let's officially call this equation star. So let's rewrite equation star as this. Let's just put this guy over here and this guy over here. Let's just switch spots. Okay? So the price of pizza over the price of beer equals the marginal utility of pizza over the marginal utility of beer. I'm taking that same thought process and I just want to think about it a little bit differently. Now, if we put the numbers that I had in here for you, what was the price of pizza? $2. So just for the, if you'll spare me this here, $2, we usually put the dollar sign over here, but we're giving up $2 for every pizza. Divided by, beer was how much? $1. $1 for every beer. What does this equation tell us? This answer of 2. What does this tell us? 2 what? Those of you who are a little more mathematically inclined, if I've got a fraction in the denominator, how do I solve it? Flip it over, multiply it times the numerator. What is this 2? What is it telling you? What is this 2 telling you? Raj? 2 beers per pizza. So look at what we've done. We've taken the dollars and we've kind of flipped them around saying, what can I really trade for? In the market, I'm being told I can trade 2 beers for every pizza. I didn't really think about it. I might have thought about it implicitly when I look at the pricing menu and it says pizza's $2 and beer is $1. Oh, okay, I get it. If I buy a pizza, I'm giving up 2 beers. But this throws it right in your face, doesn't it? It kind of solves it for you. Now, we could take the price of beer over the price of pizza, and this would equal 1/2. What is it telling you now? 1/2 what? 1 beer, a half a beer, or 1 pizza, a half a pizza, half. So that's why I like to do this little dollars per beer and dollars per pizza. Pizza goes on top. A half of a pizza is equal to one beer. Right? So it kind of puts that right into perspective for us. And this is called the relative price. This was introduced to you, I think, in chapter 1 or 2. And the textbook calls this the relative price. Sometimes also called the real price. Would you call this the relative price of pizza or the relative price of beer? Pizza, right? Because we're quoting it in terms of beers. So, what does a pizza cost me? Oh, it'll cost you 2 beers. Right? We always say $2, but now we're starting to see how each decision we make has a cost. The opportunity cost is what we gave up to do it. Well, we can do this with anything. What does that calculator run at Walmart, brand new, your T81? Is it a T83? What is it called?
T84.
T84. And what did that soda run you at the? You might have got it free and took it out of there, but what would that run you at the? Maybe I should go to. Well, if they got a bag of chips. Well, let's do your soda. You go to the convenience store and buy what Holden's holding up there. What's that going to run you? 89 cents. So we got the price of soda at 89 cents. And so what did you say that thing cost?
About
108 bucks divided by 89 cents. Somebody with a calculator, what's 108 divided by 0.89? Yeah, I guess somebody happens to have a calculator here. That's convenient. 121.34. And what is this number? How many sodas you gave up to buy the calculator, right? You don't ever think about it that way. Oh, I gave up 121 sodas. But if you have pricing data, you can do this for anything. And you can start to kind of get the notion of what you're giving up to get something else in terms of the physical quantity by using the price tags that are out there. Okay, so that's one concept here, the relative price. And the next thing I want you to note is that this is given by the market. The market system, our system of capitalism, gives us what these prices go, and we'll continue to talk about throughout the semester on where these prices come from. But that relative price is given to us in this problem. This is what the prices are, you decide. Now this over here is kind of your willingness to trade one good for the other. The ratio of the marginal utilities shows the willingness to trade beer for pizza. Our willingness to trade beer for pizza. Remember, this was different for everybody that came to the board, right? We had that internal clock of utility that I claimed that we could make a happiness calculator, but we wouldn't be able to compare that happiness across individuals. But we could do it for the individual, and by looking at this ratio, we start to see the willingness to trade one good for the other. So what was the marginal utility of pizza at the optimal level? What was the marginal utility of pizza? So just the MU, not this statistic, but just the marginal utility of pizza at the quantity of 3 from our table. 5. And what was the marginal utility of beer from our table at the optimal quantity? Was it 5? Yeah, pizza was 10, right? You grabbed onto the marginal utility per dollar number when you said 5. The marginal utility only was 10. So if you go back on your table and look, the marginal utility of pizza at a level of 3 was 10. The marginal utility of beer at 4 units was, there's your 5. 10 divided by 5. 10 what 10 units of happiness, 10 units of utility per pizza, and 5 units of utility per beer, which means I get 2 beers for the pizza. So I'm willing to trade 2 beers for a pizza in my gut, right? That's my internal trade-off. Kind of like those guys in the video, we might face different trade-offs depending on what unit of beer we're eating, or Kobayashi eating the next slice of pizza after he garbled them up in, what was his time on that? A minute? It was less than a minute, right? How much?
55 seconds.
55 seconds. Probably 8 slices of pretty good sized pizza. That is crazy, right? But so we're looking at kind of the internal trade-offs, and in equilibrium, those two things are equal. So if they're not equal again, it means that you can be made happier by going to the market and reallocating your budget. This is kind of a different way of looking at it. Okay, questions there? We're going to chip away a little bit more here by graphing the budget constraint. Graphing the budget constraint. All right, so I want to go into beer and pizza space. Quantity of beer, quantity of pizza. Notice not demand, like where we'd be measuring the price of pizza here, but this is in quantity space. What was our budget deal with this problem? We had $10 and we knew the prices. So what does my spending equation look like? What if you were to put on some equation goggles now and imagine your budget? What do you got? You've got $10. Maybe I'll throw it over here. You've got $10. And you got to spend it all, or you don't have to spend it all, but you can't spend more than what you got. And so what does that spending equation look like? What's the one?
The 1 is the price.
The price. So we've got the price of the beer
Plus the price of pizza.
times the quantity of beer, right? That's beer spending. And then our pizza spending is just the price of pizza times the quantity of pizza. I did this in 2 steps so that we can now put your $1 in here. We know that we can buy that for $1, and we know that this is $2. And what we're doing for the consumer problem is figuring out the best way to spend our money. So we got $1. I'll shift this over here. Sorry, I didn't mean to nix you guys over there. So our total spending equation, let me write that here, is my income has got to be equal to the price of beer times the quantity of beer plus the price of pizza times the quantity of pizza. That's it. So we got beer spending, pizza spending, combined together can't be more than my income. No big deal. Now, if I'm going to try to graph this concept, knowing that my income, using from the numbers from the same example here, income's 10, price of beer is $1, price of pizza is $2. How does that look in the graph, or the graph? How does that look? My cameraman's having trouble coming all the way here. Who's got some good graphing goggles this morning? Give me 1 point. So give me 1 point. 1/2. What are you doing there? And I want a point on this kind of budget constraint here. Another thing is, give me one possible combination of purchases I can do with my $10. 4 beers and 3 pizzas. That was our solution we did over here. That one worked, right? So let's go ahead and do that. 1, 2, 3, 4, and 1, 2, 3, 4. We had, from our solution we did, we came up with 3 and 4. That was 1 point on the budget constraint. Everybody agree we spent all of our $10, right? We spent all of our money, so we followed our budget okay. So now what I'm asking, give me another point. What's another possible combination? 5 pizzas and 0 beers. So what if I spend all my money on pizza? Pizza runs $2. I have $10, so I can blow everything on pizza. So another point would be right here on the horizontal axis. I'm going to, not liking how crunchy I'm getting down there. So.
You said you don't have to spend it all, or do we have to spend it?
Well, in theory, you don't have to spend it all, but we're going to look at what the constraint is, kind of the outer boundary showing the maximum that we can do. I'm just redrawing what you guys got down there. 1, 2, 3, 4, 5. So one combination was here, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What's another combination? 10. I can blow all my money on beer. I can blow all my money on pizza. I can be somewhere in between. And if you draw this real carefully, what can you tell me about these points here? They all fall in a line. Good. So if you draw them carefully, you would have all possible combinations on a straight line. So go ahead and draw your straight line. That is your graph of the budget line. Now, more generally, we can take this equation and make it look like a straight line. What's the slope-intercept form of a straight line? Y equals mx plus b. If we remember that way, there might be other ways that you guys did it. But some sort of y equals mx plus b is what the one version of slope-intercept form that is in your appendix. Chapter 1 appendix has all the slope of a line stuff in it. We don't have a y-axis. What do we got? A beer axis, right? So we've got a QB over here. We've got the the quantity of pizza over here, which is our x. So do it. Take this equation, I equals PB times QB, plus take this equation and do what with it to put it in this form? What's my y again, Sarah? Beer. My y is my beer, so get B over here, get all the other junk over to the left. Go ahead and do it. Solve for QB. Your final thing should say QB equals some other junk over here. I'll come around and see how you're doing. Okay, good. And then take this one step further and distribute that. Yeah. Just to give a solid slope and intercept. It'll help. All right, so that's the beer, remember? So this is B and B. Don't put the D there. Okay, and then you got P, price of pizza, times quantity of pizza. All right, so then first step might be to get this all that chunk over and yep, start solving for QB. Ooh, getting close here. So you lost the I part over here. So first step would be to take this and maybe switch spots. Like if you can think of it as kind of bringing this over to here is one way to do it. So we get I minus, there's a couple different ways, so you might not jive it this way, but PB times QB, big Q, sorry. And then get rid of the B. And then you've got it. Now you get rid of that by dividing this side, divide that side, and you got it. Oops. I want to take your keys. Well, maybe I do.
Yeah.
How you guys doing? Okay, and then distribute that P term across those two. All right, looks like some of you are onto this. I just wanted to give you a chance to engage your brain on it before I just feed it to you, which I'm going to do next, so you will eventually get fed. So I might have done this kind of in my brain as bringing this sucker over here, leaving this, and then flipping them around. So your brains might not work that way, that's fine. There's multiple ways to do it, but you might get something like looks like that. I want this sucker all by itself, so I'm going to divide by the PB to get rid of it. What I do to one side of the equation, I got to do the other. I get I over the price minus PP over PB times QP. Slope-intercept form. What's the slope? It'd be 2 putting those numbers in, but what component of this is the slope in general? That relative price, right? The price of pizza over the price of beer, that relative price, that is the slope of the budget line. So that is the slope. And this one has kind of a nice interpretation too. I spend all my money on beer. Well, I mean, that's not maybe nice, is stretching it, but, right? I've got 10 bucks. Beer is $1. I can have 10 of them. Right? So this is the intercept graphically. This is the intercept. And there we've done it. And that's exactly what we found over here, was that if I spent my whole income on beer, I had that much. That represented 1 point there. The slope of this line is 2. Rise over run, down 10 over 5. How did we get that? Well, it happens to be equal to the price of pizza over the price of beer, which equaled -2 over 1, which equaled -2. Rise over run. It all kind of works together. Now, you can have any quantity in here. What does it mean to be inside this line if we were at point like this one, where there's 1 pizza and 4 beers? We just didn't use all of our money, right? We didn't spend all of our money. So this line represents the outer boundary of our spending, our budget constraint. If money doesn't give us any happiness, which I would claim is actually true at a fundamental level as well as many other levels, but it's the stuff that money buys that gives us happiness, right? So if we don't leave room in our budget for leftover money through future consumption for savings, that gets into more complicated details. We don't have to worry about it. Right.
With that graph, you can only have whole numbers, right? You can't ever have like half a beer, or you can't really buy half a pizza.
Yeah, depending on the problem, like when we have our schedule goggles on, it'll all be in kind of whole numbers. And so the map will always work out on that it works out nice and neat, but so that we don't have halves or 3/4 or whatever. Because you're right, as we move along here, apparently 2.5 and 5 falls right on there. We'd have to get into incremental units to be moving along the line. Okay, so what happens when prices change? So what if there's a increase in prices? What happens if there is an increase in the price of beer from $1 to $2? What happens to the budget line? So by the way, we call this the budget line, since it's a line is another word that's used here. So this is the budget line, maybe affectionately called the B line. Price of beer goes up from $1 to $2. What happens to the old B line here? It kind of doesn't quite shift, so be careful. The slope gets, more flat. I want to be careful using the word elastic because it's not the demand curve at this point, but it does come in. So this is going to rotate inward. So let's call this movement of the budget line. Number one, if there's an increase in the price of beer, that leads to a rotation around the horizontal axis. Sounds a little weird here, but once we draw a quick little picture, we don't have to draw in quite all the details. So we'll do kind of a quickie here. It's going to rotate inward. I can still buy just as much pizza as I used to, is kind of the intuition of it, but I can't buy as much beer. And so that whole possibilities of purchases cranks inward from price going up. Okay, questions on that? What about an increase in income? Maybe we go from $10 to $20. What happens to the budget line? Shifts to the right now, right? So we can have not only more pizza. I used to be able to buy 5. Now that I have $20 instead of 10, how many can I buy? 10. I can double my purchases. I can also double my beer consumption from 10 to 20 if, again, I spend all my money on that good. So an increase in income leads to a parallel, and I'm not sure I can spell parallel. We got a couple L's in there somewhere. Parallel shift outward. So graphically, if we were here again, quantity of beer, quantity of pizza, we're going to have a parallel shift. I didn't do a very good parallel there. We're going to have a parallel shift outward. So that both endpoints are going out. So for example, the initial income was 10 and now the new income is 20. We got $20, we can double everything. All right, questions on that? right, last one. What if we decrease the price of pizza?
Rotation on the vertical axis.
Good. Rotation around the vertical axis, right? So we used to have 5. Now pizza's cheaper. Maybe it dropped to $1, just for example, if this was at 10. And then that would cause us to be able to buy double the amount of pizza. I can't have any more beer, but I can have double the amount of pizza now. So it rotates outward this way. Rotation outward around the vertical intercept. Okay, so we went through a bunch of different things. You can see, looking at the equation now, putting in a new number here makes this get bigger, this stays the same, that intercept would change, and it would move accordingly. If we had one of those being changed, if one of the prices changes, we can kind of look at the equation and see how that would just change the look of it. All right, questions there? All right, so the next thing I want to bring into the table is the happiness part. This is all about the budget, but it doesn't speak to our happiness trade-offs, which is what we're going to do next with what we call indifference curves. So let's see here. I think I'll keep that up for now. So adding utility to quantity space. I know that sounds kind of exotic, but I hopefully we'll get a picture of what this looks like. So we'll stick with beer and pizza. We got pizza down there and the quantity of beer here. And we've got the budget thing down, but that had nothing to do with our preferences. That didn't tell us how much we like pizza or hate beer or anything, right? We didn't have anything of the happiness part built into that. That was strictly the budget constraint that we were facing. Our income and those prices allow us to be at point A, point B, point C. We could be anywhere along here. What point do we choose? We choose the one that makes us the happiest. What does that look like? All right, well, before we jump there, I think it was maybe the very first graph I gave you was total utility and quantity of pizza. Now look back in your notes. What did that one look like? Going up, so happiness goes up as I consume more pizza, but at what? At a decreasing rate or a diminishing rate. So that graph looked like this. The total utility function went up at a diminishing rate. The law of diminishing marginal utility was tied into that. All right, so now I want to think about utility and the interaction of quantity of pizza and quantity of beer. And I like to try this every year or every time I teach this class, but it usually doesn't go so well. And that is drawing a three-dimensional graph. So here we go. Here's the quantity of beer axis. And then this thing ends up being kind of this canopy going over. And I already suck at it. So I'm better off using your imagination. And then we're going to stick in two-dimensional space, so bear with me. I want to take the classroom and turn it into an economics laboratory for a sec. The vertical axis is this wall where this wall meets this wall right here, this corner. Running along where the wall meets the floor all the way down there is our beer axis. And where this wall meets the floor is our pizza axis. So the floor represents this two-dimensional space, right? We've got beer and pizza there, and we're measuring happiness as we go up. And what this utility function looks like in three-dimensional space is kind of like a big canopy coming up over the classroom. So it starts down here at the corner. Remember, no beer, no pizza, no happiness. And as we start to consume more of both, this big umbrella comes reaching right over the class, right? Kind of a big umbrella coming out, kind of curved because it's following these principles, coming up and over the classroom. Now, to get it into this space, I'm going to take out my samurai sword and hold fixed the level of utility at a certain amount. Remember how we did the 100 units of satisfaction for Lydia and Zach and everybody? I'm going to find where their utility is constant at 100. I'm going to take my samurai sword and cut through the umbrella. And where it cuts, I'm going to drop that slice straight to the floor. That slice looks like this. Am I blowing your minds yet? So that is the indifference curve that shows the internal trade-offs that you have for each good. As we consume a point like way over here at point A, look at the trade-offs here. In other words, how do I keep myself at an indifference curve with 100 units of satisfaction if how much will I have to take away to maintain happiness of 100? So as I move this way along here, we can think about getting more pizza. Do the early units of pizza, the first slice, the second slice, do those give you lots of happiness or a little bit of happiness relative to later slices? Kobayashi reaching the end of his pizza. Which one gives you more happiness, the first slice and second slice, or the fifth, sixth, and seventh slice? The first slices, right? So we've got that relationship going on, being reflected in the trade-offs. In other words, this consumer is willing to give up a whole bunch of beer because, remember, they got a whole bunch of beer. They're sitting here with a 30-pack, and it's like, well, geez, I'm hungry. That first pizza, I'd give up 10 of these suckers to get it, right? Because I've got so much beer already. And so it starts to capture this trade-off going on for the consumer. And that trade-off is the slope of the indifference curve. Now we learned something about slopes of curves. How do we find slopes of curves? Rise over run of what? The tangent line, right? So at point A, we can look at the trade-offs that this consumer is willing to make between beer and pizza by finding the slope of the tangent line at point A. At point A, the consumer is willing to give up a whole bunch of beer to get a little bit of pizza. Because the first pizza tastes so good. And I've already got so much beer, I'll be willing to give up a whole bunch of it. As the night goes on, and maybe your buzz wears off, and you're full, look at the trade-off now. Right? In order for you to get more pizza, you're not going to be willing to give up any beer because you're down to just a few left, right? And so the trade-off is different depending on where we are on the indifference curve. Okay? So the slope of the indifference curve is that ratio of the marginal utilities that I derived for you earlier. So let me jot some of this stuff down. The indifference curve. Also called the I curve here. Shows various combinations of two goods that leave a consumer with the same amount of utility. We call it an indifference curve because they are truly indifferent between point A, B, and C. Point A reflects a lot of beer and a little pizza. Point C reflects a lot of pizza and a little beer, and they don't care. They are indifferent between those combinations. So consumer is indifferent between combinations, which is points, along the indifference curve. Because utility is fixed at 100. Now, I drew one of them. If I double the satisfaction and go to 200, and I take out my samurai sword, slice the umbrella, drop that slice straight to the floor, where does that slice live relative to this slice? Further out. Further out. Remember, the canopy's coming from the bottom and it's coming out this way. So if I take a higher slice, I'm actually out further in the classroom. I drop it straight to the floor, and I've got another indifference curve somewhere. I'm going to put U200 here, just to say 200 units of satisfaction might be somewhere further out. So the indifference curves I don't like to think of as shifting, because the entire preference map is already there when we draw it. In other words, probably the best picture of the indifference curve is this one. There, I just drew it. See them all there? I drew them in white. There's an infinite number of these, depending on where I cut the slice. I can do an infinite number of slices along this cut. And so really, the indifference map, we call it, is all there, all at one time. And so our preference structure is defined by the contours of the indifference curves. And I'm happier the further out I am. So the further out you are on the indifference curves, the higher the total utility is. So we might call this the indifference map. All right. These indifference curves, kind of tell us about the person a little bit. So we have different preferences look a little different. And so let's look at some extreme cases. I think this actually helps kind of view the shape of the indifference curve. So what if we were looking at a pair of shoes and we had the quantity of left shoes on the vertical axis and the quantity of right shoes on the horizontal axis? And assuming you're not one of those people, you know those people that wear two different shoes and they do it on purpose. Let's just say that you like to always wear your shoes that match. So how does the indifference map look when we have perfect complements? Two goods that only give us satisfaction when they're consumed in this one-to-one basis. Straight line, there is some straight lines, but let's go 1, 2, I guess 3, and 1, 2, 3. So does everybody agree that my first pair of shoes makes me happy? One right shoe, one left shoe. There's a point on my indifference curve that might give me 100 units of satisfaction. If I get a second left shoe, but it doesn't come with another right, am I any happier? No. So my happiness level stays at 100, right? Because I still have this pair to use, but I don't get any extra happier from having a left shoe if it's not accompanied by a right. Same thing if you give me a third, you can give me as many as you want. I'm not going to get any happier if it's not accompanied by another right shoe. Same thing with the right. If you give me a second right, but you don't give me another left, there's another point of indifference, not making me any happier. And so the indifference curves are right angles. How do I get happier? Well, you give me two shoes, and then you've got the same thing. So these are a couple extreme cases, or an extreme case, one extreme case, where these two goods are perfect complements. You can see how this ties in a little bit to our consumer theory. They're perfect complements. We talked about whether the price of complements and the price of substitutes, so this is kind of playing into that discussion. All right, questions on that? All right. If you are a Coke and Pepsi person, and the two are perfect substitutes for you. You don't care if it's Coke or if it's Pepsi, right? Doesn't matter. What do those indifference curves look like? One, two, three. 1, 2, 3. What do those look like? Pick one or the other. What do you think? The right angle be flipped. Well, let's tell the story this way. If you had 3 Pepsis and 0 Cokes, and you view them as perfect substitutes, what's another point that would leave you just as happy? 3 Cokes and 0 Pepsis. Or you might be at a fraction of each. 2 of this one, 1 of this one. But if we did that, as long as they're equal, we'd have that 1-to-1 trade-off. So our utility curves at 100 might look like this. The only way I get happier is if you give me more of one or the other. It doesn't matter. I'm equally happy. That is perfect substitutes. Feel free to get up and look around. Sorry, I can probably move this a little bit too. Didn't quite set it up all the way. All right. Now you can see what's going on here is that, well, this, depending on if this is kind of like this or if it's kind of flatter, tells you how much beer and pizza are either kind of substitutes for each other or kind of complements, depending on how flat or steep or how curvy those are. That's what's kind of helpful to look at these extremes. What is this person? If we've got quantity of beer, quantity of pizza, and the indifference curves look like this. Don't like beer? All right, so if you give me this much beer and this much pizza, if it's 3 slices, you can keep giving me beer all day long, but I'm not getting any happier, right? In fact, you can take all the beer away, right? You could take all the beer away and it doesn't matter to me. So I'm kind of a beer hater, right? Or a pizza lover, but I know I don't like beer. So this person's more of a beer hater. Because they don't get any satisfaction from beer whatsoever if it's perfectly vertical like this. And so, kind of a little rule, or a little kind of hint here, I guess, is the I curves point to the thing you like or love. Put little arrows on there visually. You can kind of think of, I like pizza. I don't care so much for beer. All right. So, let's, I guess I kind of went off there. I did this visually, but I didn't leave you with it. You guys want to draw yourselves a couple tangent lines here. The slope of the indifference curve. So the slope at a point is the marginal utility of pizza over the marginal utility of beer. And it's equal to the rise over the run of that tangent line where you drew it. You're at point A, point B, point C. Take the slope of that tangent line. What you're really doing is finding out that ratio of the marginal utilities that we discussed earlier. All right, questions there? Got one last thing and then we'll be done with this section. And that is showing your optimal condition. So this is consumer equilibrium graphically. Quantity of beer, quantity of pizza. some sort of budget constraint now. This is the budget line. The budget line has an intercept of, if I take my income and I divide it by the price of beer, that's how much I could have, right? Right there. I could be anywhere along this line. I can afford to be anywhere along this line given my income. Where am I going to be? Well, I get happier as I move away from the origin. More is preferred to less. And would I want to be, I don't know, here if I have an indifference curve that looks like this? If my utility is equal to 100, is point A a good point to be at?
You can be happier.
You can be happier. Why do you say that? You're right, by the way, if that gives you a little confidence.
You're not, that margin of space between two intersects.
Okay.
Because you want to get at.
So first of all, let's recap that we are spending all of our money at point A, right? We are spending all of our money, but have we maximized our utility? Have we maximized satisfaction? Todd says no. And part of it's we've got this little football region. What does that, Kyler, what does that mean? Okay, so we want this budget line to be tangent to the utility, so should I shift the budget line backwards? Right, and remember, I'm not really shifting anything at all, am I? Because again, all of the indifference curves are there. I just happen to show you one of them. And I said, so my question on the problem might have been something like this. Suppose a person is currently consuming at point A, and their utility, their indifference curves are reflected the way this graph looks. And the question was, are they maximizing utility? The answer is no, because we know that there is a higher samurai sword chop that would be further out. And in equilibrium, we know that there is going to be some indifference curve. I don't know where it is, but I know that there's 1 point and 1 point only that maximizes utility. There's no more little football half moon region here, right? And this is the optimal quantity of beer and pizza. Graphically, we didn't do this, but graphically, this is the 3 pizzas, if you will, and the 4 beers. This is the quantity that maximizes satisfaction, 4 and 3. And it obeys our profit maximizing condition, which was this. But now it's in a little bit different light with all the stuff that we've kind of piled on. The price ratio is the slope of the budget line. This is the slope of the indifference curve. So if I was to take that golf club, this point right here is also a tangent point. Let's call it point C. We'll call this one B, I guess, for fun. Point C gives me 200 units of satisfaction. But what's true about it? Why wouldn't I pick C? It's outside of my budget, that's right. It requires more money than I got. I can't afford C, but I can afford B. And B leaves me just as happy, and I can afford it. and there's only one point where that's true, and that's where the slope of the indifference curve happens to be equal to the slope of the budget constraint. And so point B is our consumer equilibrium. So this is point B on our graph, where that happens. Back to point A for a second. Remember where we said we could do better? Check it out. The slope of the indifference curve at point A does not equal the slope of the budget line, which means we can do better by reallocating our budget. How? Go get yourself some more pizza and give up some of the beer. And then you can move along it to point B, and you'll be made happier. All right. Boy, that, I don't think we're going to get much more, I can guarantee you, we're not going to get any more abstract than that. I know that this kind of seems like a load of crap sometimes, but I like bringing it to you because I think there's some good gut feelings in it, right? And we can kind of hopefully get some insights about the consumer and the trade-offs that they face and how they make those purchases. So thank you for bearing with me, and I promise we'll get down to real live stuff that's maybe a little easier that clicks with you a little bit easier than some of this utility stuff. Okay, questions or comments there? I brought you a long way. We went from that two-dimensional thing, three-dimensional, back to two-dimensional. There's a lot of stuff there that you probably have to kind of review. I'll have the tapes online too if you need some review at some point. All right, so that closes out chapter 9. So all of this utility business was chapters 8 and 9. That was it for that. And we're going to have just kind of some special work for that in terms of the in-class tests that we're going to have. So I'll have a special, and this won't be till down the road here, probably next week at this point. But I'll get back to you on the time. But part of your points is short answer questions, and so that's where we're going to hit some of this is in the in-class test. All right, let's talk about businesses, which is usually a little easier and less abstract. What we spent all this time doing was really drilling down into the consumer theory. We wanted to know what makes these consumers tick. And now we're going to spend a larger portion of our time on profit maximization and learning about the firm or companies, businesses. To kind of step back and look at the forest for a moment, since we got pretty deep into the trees here, if you maybe go back to this picture, we've got households, businesses. They're exchanging in the resource market for land, labor, capital, and entrepreneurship, the basic resources. And they're trading in the output market for beer and pizza and all of that stuff, right? What we did is we drilled down pretty deep into households with what we call consumer theory. That's what we just left, thinking about these indifference curves and utility and all that stuff. Now we're going to spend time on the other side of the island looking at the producers in detail, what we sometimes call producer theory. All right, so let's see. So this is chapter 10. Limited reading. On your syllabus, this is actually only pages 227 through 232. It's only like 4 to 5 pages. I skipped part of that chapter because it's just stuff. There's only so many hours to put in, so I'm kind of limiting, even though it's kind of good stuff. So limited reading, see your syllabus that it's just on kind of the front pages, about the first 5 pages of chapter 10. And what we're looking at is producer theory. And we're going to spend a lot of time on profit maximization. Profit maximization. We've done this a few times. What's that profit equation? Profits, which I do with the little pi, is equal to total revenue or total sales revenue, right? So total revenue minus total cost. Total revenue minus total cost. We're going to spend a lot of time in chapter 11 looking at this side of the equation. So this is chapter 11. Chapter 10, we're just kind of introducing the equation. We'll spend a lot of time on the revenue side, more in chapters 12, 13, 14, and on kind of the interaction of these two things. It's not like we ignored this, but we built this up in chapter 11, and then we start to kind of put all the pictures together, all the things together. So that's kind of where I'm taking you on the journey here. So we're going to first look at these profits. And I think it's best done with just an example. So, example. Suppose there's an English professor. Suppose there is an English professor who is opening a restaurant called what? What's our restaurant called? Some unique name. I don't want Applebee's or something, but so it's an English professor opening up a restaurant. What'd you say? Essays. All right, called Essays. Essays, and we need something food related to that. Let's just build on that. I like it. Essays and easy over essays, like eggs over easy, essays over easy.
Essays sound like Spanish, but Mexican.
Essays what?
Spelled
Mexican
Spanish.
food. Just leave it at essays.
Oh, why is that? Does that mean something in Spanish, or it just sounds like it? Essays and escargot. What's something that essay and eggs? Essays and eggs. Maybe it's a breakfast place. I don't know. All right, we'll just call it essays. Essays and waffles. All right. So we got the grid lines or something. So let's just call it. Okay, we'll go with essays. So, so opening up a restaurant called Essays and estimates the following costs. Estimates the following costs. So it's kind of going down the list. We're going to lump a bunch together here. We've got the rent for the building, and that is $50,000 a year. I'm going to use K for thousand, 50,000. So 50 grand per year. We've got grills, coolers, other sorts of fryers and equipment. What economists call what? What would we call the grills, cooler? Capital, right? So we got some capital equipment, and that stuff's going to run $200,000 a year. Let's say that he's got maybe some sort of lease agreement going or something, and maybe maintenance and whatever. Estimates $200,000 a year. And then we've got some labor in the form of cooks and wait staff, dishwashers, all of those people running in at $110,000 per year. Okay. So the ex-professor used to make $60,000 at the university, OU. But will now pay himself $35,000 so that he does not have to hire a manager, i.e. the kind of the market rate for a manager was $35,000. So he's going to be an active participant in the restaurant to the tune of the $35,000. So if total revenue is $400,000, what is the English professor's profit? If total revenue equals $400,000, what is total profit?
Now, is that 45,000 including besides labor pension, or is that outside of the labor?
It's outside of this labor section, yes. All right, let me give you a couple minutes. You can work with your neighbor. If total revenue is $400,000, talk to your neighbor, come up with what the total profit is for this little case study we got going for the English professor. Okay. See, some of you had some answers down. Let me hear some of your answers. 5,000. So let's see. How'd you calculate 5? So profits equal 400K minus, what'd you do? Take these, add them up, 250, 360, and then minus the 35 equals 5,000. Did anybody get anything different? What'd you get?
We had 75,000.
75,000. What'd you do?
We added his 35,000 to the total revenue because he pays himself.
Okay.
And subtracted out the costs.
So walk me through it again here. We got the 400
Plus 35.
plus the 35
Minus the cost.
minus this cost, which are these same costs. So if you allow me to, we could take 400,000 minus the 360. Oh wait, you got it up to 70. Let me just hang with you. 460 minus the plus the 35 that he pays himself, and then what?
Minus the 360.
Minus the 360. And what'd you get for an answer? 400, 3. So yeah, that is equal 75.
Yep.
Okay.
I got 15.
You got 15. How'd you do it?
I did 400 minus 360.
Okay.
And then he used to get paid 60K.
Okay.
So I took that away from what he's making now, which is technically 75, because it's 40 left over from that 400K, and then plus 35, which is 75, minus 65, minus 60, which is 15.
So he did it our way. And
Kind
then took
of.
out the 60.
So you did it this way, but then you
Minus the 60.
subtracted off the 60.
Yeah.
Okay.
Take it a step
So
further.
let's see, minus the 360. Minus the 60, I guess, is the part you're adding in to get 15. Right?
You just take a step further than ours.
Because I'm just adding in that would give you the difference of the 15.
Instead of that first.
All right, so let me back up a second. If you're the English professor, never took a business class, whatever, how much money did you make when you ran this restaurant? 40 grand. Yeah. I didn't hear anybody say 40 yet. So isn't that the amount that's really in the English professor's hand? Ignoring IRS taxing, we're not going to tell stories like that.
Yeah.
But if we think about it, the English professor, I mean, let's not lose our wits about us here. I got some fun things going on here. But as far as the English professor is concerned, we've just got the 400 minus the 360 gives us the 40. All right, so the English professor might calculate the profit this way. Say, hey, I got 40 grand at the end of the day. Now let me go up to your 5 up here.
5K is the rest.
Why would this one be important, or what distinction does that bring?
That's the restaurant.
Okay, so the restaurant. So, and possibly there could be sometimes some tax advantages or something like when the English professor brought their books to their accountant said, hey, you know, we got to look at what the restaurant's making versus what you're making. You're kind of being there, so let's just put in that 35. And so maybe the accountant said that there's it's better for you to take pay this way, but it can't be too much. It has to be, you know, market rate. Maybe there's some tax advantages or something that way. I don't know. So we've got 5,000, and then and we got 40,000, and then, you know, the English professor's response to that, oh, well, that's your department accountant. I don't care what you do. I know at the end of the day I got 40. And you can call it, I made 35 here with this hat on and 5 here, but at the end of the day, 35 plus 5 is 40. Same thing to me. I don't care. Okay. Question?
I
Comment?
would say still with that 40, because he's paying himself, doesn't he have to add that 35 back in? Because that's part of his money too.
Well, here he's getting paid the 35 here, and
That's
the
what it
restaurant
is.
makes 5,
I
because
get-
then
I
it's a
get
real
that.
expense.
I get that what I'm saying for the bottom part, for his term cash in hand, like you were saying.
Uh-huh.
It shouldn't be that 75, because he is also getting that 35.
But he's
No,
also-
no, we've taken that into account because that was left over. Because then the restaurant has to have that expense, so we're not. That doesn't come out. That doesn't drop out of the air from anywhere. It's not a part of this at all. So if the restaurant absorbs that cost, then this equation's correct, and we just have 5 plus 35. Okay. All right. So none of these two ways are wrong. I mean, they're just different ways of calculating the same thing. There might be some tax advantages here. But none of those accomplish what the economist wants profits to do. So what is the English professor really better off financially running the restaurant and making 5 grand or 40 grand, no matter how he slices it? No, why?
He's making less than he was before.
Making less than what he was before. Right? So he was making 60. Again, I'm kind of ignoring the fact that he hates you college kids now. He couldn't stand to jump into another classroom, right? I'm not talking about that, which may or may not be true. That would be some offsetting differentials. But from a pure finance standpoint here, he is giving up 60 grand to do this job. So if we think about our opportunity cost, how would an economist or a young sprouting economic mind in economic principles class calculate the profits.
Just a side question. As
Okay.
far as like the fact that now he can make his own hours and stuff like that, would that go into the category where he doesn't like
In a
teaching
real life
stuff like that?
situation, perhaps, yeah.
I didn't know if
Yeah,
that would call it.
but not here, just sticking straight to the numbers. Holden?
Oh, yeah, if we're just gonna say the numbers, I was just gonna say, would he technically build himself equity by, if he owns said building and all the equipment?
No, we don't know that if he's leasing the equipment, so that'd be reading too much into the story. So, but there's something here that we can pick up by thinking about the English professor's opportunity cost. Opportunity cost is the thing you could be doing if you didn't do what you were doing. So what would be the appropriate way to handle that 60? Go ahead. Oh, yeah, go ahead. I'm sorry, give me your name again.
Margaret.
Margaret, okay.
He foregoes 20 grand to be happier.
Okay, yeah, we can start to break it down. So if I think about the pure profit equation, how do you want to manipulate to capture that idea? What should he be paying himself, so to speak? 60 grand. If we think about his opportunity costs. 35 grand is not the right number for him. It might be the right number for the accounting and for the IRS, because the IRS probably wouldn't like it if, well, I'm going to pay myself 60, oh, and then my business actually lost money.
So you should be free.
So what does the profit end up being for the economic way of looking at it by including the professor's opportunity cost? Negative 20, that's right. And that is an important distinction, a crucial distinction here for another way to calculate profits. So if we take the 360K, whoops, I need the 400 up there first. If we take the 400,000 of total revenue, minus the 360, minus the 60, we get a negative 20,000. Now, once again, the English professor might say, oh, you economists, you accountants, you got different ways of doing anything, I don't care. I know that I got 40 in my hand, right? But you can see right away what he's giving up compared to the real 40 that's in his hand, that eventually when he's sleeping at night and he's only making 40 for putting in all the hours at this job, he's going to start to be thinking to himself, what? I could have been making 60. It's kind of like I'm losing 20. Well, you know why? Because you're really losing 20, right? And that's what the economist says. Now, we can't use that expense to write off for the IRS purposes, but from a decision-making standpoint, you are really losing 20. All right, so this little bit here reflects the opportunity cost, which we've touted as being so important. In fact, I would say it is definitely in the top 3 of all economic principles, is beginning to learn and include opportunity cost as part of your calculation. All right, so this is the econ way of doing it. This is what we call economic profit. And the lesson here is that our total cost from an economic standpoint, TC, is equal to explicit cost plus implicit cost. Total cost for the econ way of looking at it. So this is, if this is econ total cost becomes opportunity cost when we include both explicit and implicit cost. What do I mean by explicit? Well, it's pretty easy to see what they are, right? The grills, I bought it for $10,000. The cost was $10,000. It was very explicit, right? In writing, it's actual purchases. So accountants especially, are looking at these explicit costs. Easy to see And economists kind of specialize in mastering these types of costs. And the explicit, we don't ignore them, by the way, they just have to be added to it. Now, if the restaurant has a good year and revenues climb to 420, what is the economic profit? Zero. So if total revenues equal 420, then economic profit equals 420 minus 420, including all the things, equals 0. Does that mean you suck at what you're doing? Are zero profits bad? No, because you're breaking even with your opportunity cost, which means you can't do better elsewhere. That's an important lesson, that profits in economics class can be zero. In fact, what we're going to learn is we expect them to be zero under certain circumstances, and that's okay. Would we like more? Yeah, sure, we always like more. More is preferred to less. We learned that last time, right? So more the better, but zero is okay. So this is whoops, not a Q. This is okay. More is better, but zero means all opportunity costs are covered. All right, we'll pick up there on Wednesday. No, what is today?